Graphing functions with defined radicals. If you were given the following function, f of x is equal to the square root of x minus 3, and you were told to graph it, what would you do?
First, you want to make a table.
Make a table. Jake's saying he would go down 3. From where?
Oh no, you go right.
Right 3 from where? From the center. So you're saying you would move to the right 3 and then you go, right? How would you get other points on it? Make a table, right? Okay. So our gut is to just make a table of values. Jake's talking about all the different types of translations, which we'll get to. If you don't remember those different, huh?
This is what you got. Apparently simplify it.
What do you mean simplify it? It is what it is. All right, so let's make a table of values. Now, the only problem that occurs with square root functions, go back to what we were just saying, what cannot occur underneath the radical sign?
It can't be negative.
A negative, right? So what number should I start with for my x so that it will not be negative? 3? 3, right?
Gives you 0,
Which would be 0, right? So when you have an even index and you're asked to graph it, usually it's smart to take the number or the expression that's underneath your radical sign, also known as the radicand. You take your radicand and you take it greater than or equal to 0. Because if I have an even index, I can't have negative numbers underneath it, which means I need to have all my x values being greater than or equal to 3. So that gives me my starting point for my x's on my table. So I'm going to pick 3. Should I pick 4? Sure. How about 5? Why would 5 not be so nice? Plug it in. What do you get? Into the original function. 5 minus 3 is 2. Is the square root of 2 a nice number?
No.
It's not a nice number.
Number.
Would I want to pick 6?
No.
Would I want to pick 7?
Yes.
Why?
2.
Because that gets you the square root of 4, which is 2. So I'm going to do 7. All right, so now plugging them in. 3 minus 3 is 0. The square root of 0 is 0. 4 minus 3 is 1. The square root of 1 is 1. 7 minus 3 is 4. The square root of 4 is 2. And that should be enough points to kind of see what's happening with our graph. I could go higher. What would be the next x value that would be nice to work with? What's your next perfect square after 4? 9. So what would your x need to be to result in a 9? 12, right? But I don't really want to graph all the way out to 12 on my x-axis. So I'll stop here. All right, so making x and y axis. Make it longer on the right side. Plotting the point 3, 0, put a dot. 4, 1, put a dot. 7, 2, 5, 6, 7, 2. So this is not a straight line, it's a curve. It's going to go like that. Now Jake was talking about translations earlier, and we'll get to that. So what happened is it shifted to the 3 units to the right. I'll talk about those once we get through the graphing part. So your calculator does something really nice for you. One, it graphs it, so you can check to make sure your graphs are correct. But another thing that your calculator does is it gives you a table of values instantaneously, so that you can then go and look to see what the nice values are to plot it. So if you have your calculator, you want to get that out. Quit out of that. All right, so whenever you're doing graphs on your calculator, the 5 buttons that are directly below your screen are your graphing buttons. Okay, so the first thing that you have to do is input your function. So hit that y equals button. And you want to input the square root of x minus 3 Your variable button is the button right next to the green alpha button. Your square root, you have to hit second and then the x squared button, that gets you your square root. So the square root of x minus 3. Do a zoom 6, that just takes you to the standard 10 by 10 axis, because you don't really know what you were doing prior to this. And it looks like my screen is all over here. There we go. All right, so there's your graph. Does it look like what we came up with? Pretty good. So now look at those top 5 buttons. Any guesses on what you think you would do to get to a table of values?
Second graph.
Good. Hit second graph to get to table.
This is like math.
Okay. And so if you, mine is up here at 6, is yours starting at the error part? So why is it saying error? It doesn't exist, right, as a real number. Imaginary, yes. Okay, so notice my first real ordered pair is at 3, 0. Then 4, 1. Well, that's 5, that's ugly, I don't want to do that. 6, that's ugly, I don't want to do that. So then you can keep scrolling through to find the nice ones that you like. Is it worth it? I don't know. Is it quicker just to plug it in and think? Or is it, yeah. So let's keep going on forever. Ashley?
Mine is going up in increments of like, what is it, 1, 3, 5, 7, and then it jumps like to 19. It's not like 1, 2, 3, 4, 5, 6.
I don't know. I'm not as familiar with the fancier new ones. Let me see. Table set, start, because it's going out to, there we go. So if you go to table set, that change in your table, like the delta table is at 2 instead of 1. All right, so back to our notes. So now let's do the same thing for cubic graphs. So if we had to graph f of x is equal to the cube root plus 2, so that plus 2 is not underneath the radical sign. Right. So now does it matter if I only have positive numbers underneath my radical sign? No, because I can have negatives, right, with odd indexes. So I can just pick any numbers I want. So in this case, since it's all real numbers, I want to pick some negatives. I probably want to pick 0, and I probably want to do some positives. What would be a smart negative number to choose? What's a nice number that you can take the cube root of?
2. Wait, negative 2.
8. Negative 8,
oh,
right?
This is cube root?
Cube roots. So we can do negative 8, and then I'm going to do positive 8.
I thought it was just old-fashioned square, you know?
Yeah, not old-fashioned
More
square.
of a traditional.
What else? Give me some numbers in between those two.
3.
Not 3. What's your next lowest perfect cube?
Calculator can tell us. This would be an
Could.
opportunity.
Negative 1 and 1. Isn't the cube root of 1, 1? The cube root of negative 1, negative 1?
Maybe.
And then 0?
Awful.
Let's be some smart ones. So, the cube root of negative 8 is negative 2. Negative 2 plus 2 is 0. And again, if you can't think about it, put in your calculator, go to the table, and find the good ones.
There you go.
The cube root of negative 1 is negative 1, plus 2 is positive 1. The cube root of 0 is 0, plus 2 is 2. Cube root of 1 is 1, plus 2 is 3. Cube root of 8 is 2, plus 2 is 4. So now let's plot them. So negative 8, 0 is all the way to the left. 3, 4, 5, 6, 7, 8. Negative 1, 1. 0, 2. 1, 3. 8. 4. And you're going to get this little curvy situation that looks like this. Okay. So, if we think about what would be the domain of this graph? All real numbers. How do we write that in interval notation? Negative, not the cute little r. Negative infinity to infinity.
Good answer.
What about the range?
Can we just write all like
Yeah, the,
Nope, put it in interval notation.
It's slight angles.
We're in advanced algebra. It would eventually hit all the y's, right? Because it doesn't stop. Eventually. It would take a very long time, right? But it would be all real numbers. If we cut back to our square root graph, can I get rid of this?
Yes.
Sorry, okay? If we cut back to our square root graph, that was over here at 3 and then going up. Oh, didn't realize that was going to be that tiny. Like in the corner of the screen and didn't know it. Where are we at? There we go. So 1, 2, 3, and then it was shooting up like this. What would be the domain of that graph?
all real numbers greater than 3.
So how do you rewrite that in interval notation?
3 and then infinity.
Yeah.
To infinity. Good. And then what about range? 0 to infinity, right? It's all the y's larger than 0. Everything's above 0. Good. Okay. Range is your y. So you start bottom to top. So my lowest bottom point is at a y of 0. And then going up higher. Okay, so now let's talk translations. Can I get rid of this? Everybody good? Do you remember all the different translations? Jake kind of remembers some of it. Maybe you'll remember some of it also. If we focus on the parent graph of just f of x is equal to the square root of x. So translations of radical graphs, focusing just on the square root graph. What would that look like? Rough sketch wise, it would be a graph at the origin and kind of going like that. All right? So sometimes, if you remember your translations, you can easily make a graph without necessarily needing to make a whole long list of table of values. So, what are the different translations that we can have? Well, the first ones are your right and left movements. So if you had f of x is equal to the square root of x minus some number k, because it's a minus, just like we had a minus 3 and it shifted it to the right 3 units, this would make you have a shift right k units. So whether that k is a minus 5 or a minus 4 or a minus 2 or a minus 1, you would shift over that many units. If it was a plus, so if we had f of x is equal to the square root of x plus k, then we would shift to the left k units. And then where does your up and down come from? The number on the outside, right? So if we had f of x is equal to the square root of x and a plus k on the outside, then I would go up k units. And if it was minus, then we would go down. So f of x is equal to the square root of x minus k means that we would go down k units. So we got our right lefts, we got our up and downs. Do you guys remember talking about this probably last year? Maybe, maybe not. And again, is it detrimental to remember them? No, because you can always make a table of values and just come up with your graph that way, but these are just kind of shortcuts. Other types of translations that can occur: if you had a negative in front of your square root sign, what happens to your graph? It does flip, but let's use more mathematical terms. How does it flip? I mean, that's what I would think in my head. It doesn't rotate. If it goes from here to here, it's reflecting over which axis? The x-axis. Good. So it's reflecting. Let's reflect over x-axis. If you wrote flip, I would accept that. Okay, and then two more things. What happens if we have actual physical numbers in front? So if we ended up something like f of x is equal to some number a times the square root of x, where a is greater than 1, so like 2 or 1.5 or 3, what's going to happen to our graph? Well, let's think about that for a second. This point here would be at 1, 1, right? If I just had my normal graph. If I plug in 1 and had a 2 in front of that, my new point would be at 1, 2, which would make my graph move up, right? So it stretches it. We call that a stretch. So then we would have a stretch. And if it was in between, so f of x with a times the square root of x, where a is in between 0 and 1, then it's the opposite of stretching, which is a compression. Which means it would compress closer to the x-axis, right? Like, think about compressing it down. All of a sudden you walked over and you're like, oh, look at this absolute value graph. I'm going to compress it down, right? Sit on it. What would happen? It would go, right? The Pixar lamp? How would you make you think of that? And the same things hold true for our cubic graphs. Do I need to rewrite it for cubic? No? Okay, so now last thing we have to talk about is domain and range. So let's do the cubic ones first because they're easiest. So domain and range of radical graphs. If we have an odd index, what did we say our domain and range was of our cubic graph that we did? All real numbers. So it doesn't matter what type of odd index it is. If it's an odd index, your domain will always be all real numbers, and your range will always be all real numbers. It's the even indexes where it gets a little bit crazier because you have all that cutoff points to your square root graphs. So for an even index, our domain is going to be, well, whatever that number was, let's say k. If I use k, are we all focusing back to what the k was from the translations? Yeah. Up to infinity. So our k in the graph that we did was 3. So I'm going from 3 up to infinity. And then your range usually is going to be from 0 to infinity. Or if there is up-down movement, and then that would change it. That would change. So if you had a +2 at the end, then you would be going from 2 up to infinity. If we had a -2 at the end, then I'd be going from -2 up to infinity. Okay? All right. Does anyone have any questions with any of that?